So please, ladies and gentlemen, I want you to tell them in the WhatsApp group that this is the link that we are going to use. So I think if you could remember, the topic that we are going to discuss today is chemistry of lipids. That is the topics that we are going to discuss, chemistry of lipids. So please, I just want you to tell them in the group that we are going to use this link. Please tell them. Okay, good evening and you are welcome. I hope you can all hear me. So the first thing that I want you to do now, check on the subscription box of this video. Please click on subscription and subscribe to the YouTube channel. So without wasting much of my time, we are going to define lipids. So ladies and gentlemen, I want to ask you, what are lipids? Because I gave you video and I asked you to watch. So now the first thing that I'm going to say, what is lipid, please? What is lipid? What are lipids? Because I know that you have already watched the video on the lipids, so we are going to have like a kind of general discussion. So what are lipids? What are lipids? What are lipids? That is the question, please. Lipids are a group of organic molecules. Lipids are a group of organic molecules that no, none of you is correct. What are lipids? What are lipids, please? What are lipids? A group of organic compounds that are insoluble in water. So I can accept this and you are correct. Because of the heterogeneity nature of the lipid, you cannot define lipid based on its chemical structure. Rather, lipids are defined as organic molecules or a group of heterogeneous organic compounds that are insoluble in water but soluble in organic solvent. So because of the nature of how the lipids are, so we can only define lipids based on their solubility, but you cannot define them based on their structure. So lipids generally are insoluble in water. They are insoluble in water, but soluble in organic solvents. So this is the best way to define lipid. So lipids are defined as a group of organic substances that are insoluble in water, but soluble in non-polar solvent, or you can call it organic solvent. So who can give me examples of organic solvents that can be used to dissolve lipid? Examples of inorganic solvents that can be used to dissolve lipids. I need examples. Please, I'm asking examples of inorganic solvent. Excellent. Chloroform, no. Ether, not ester. Ether and benzene. Yes. So these are actually, I agree that those ones are examples of organic solvent. So examples of organic solvent, we have ether, number one, we have benzene, we have toluene, we have chloroform. So all these are the examples of organic solvents that are used in dissolving lipids. So now, the next thing that we are going to look at is the functions of lipid. What are the functions of lipids? What are the functions of lipids? Please, who can tell me? Functions of lipids. I'm seeing only 34. Only 34 joints. Maybe today I will try to take attendance. So now I'm asking, what are the functions of lipids? Who can give me one of the functions of lipids? So one of the functions of lipid is serve as a storage form of energy. This is one of the functions of lipid. It serves as a storage form of energy. When you say storage form of energy, what does that means? Yes, it serves as the energy storage. Excellent. So it's actually serves as an energy storage because when there is carbohydrate, you don't need to use lipid for energy generation. Rather, lipids are generally stored in the body and they are only utilized for energy when carbohydrate is fully exhausted in the body. So now I think based on some of our previous discussion, I told you clearly the part of our body where we store lipid. So please, who can tell me examples of organs in our body that we store lipid? Please, I need answer to this. What are the examples of organs that are used in storing lipids? Examples of organs that are used in storing lipids. No, liver is not an organ. Excellent, excellent, Modester. I think I said this last time. The organs where we store lipid in our body, it majorly 90% of the lipid are stored in the adipose tissue. Adipose tissue, that is one. Then number two, Modesta said we have testes and ovaries. So it is actually classified as a storage form of energy because it only used to generate energy or to produce energy in our body when the when carbohydrate is fully exhausted. So that is when we utilize lipid for energy generation. Then another functions of lipid, and as I can see, and I also want to say something here very important, and I think I said it in one of our last video. Remember I told you between carbohydrate, proteins, and lipids, which one generates the highest amount of energy? Between lipids, proteins, and carbohydrates, which one generates the highest amount of energy? Excellent, lipids. Lipid. So lipids is actually a class of food that produce the highest amount of energy. So why is it that the lipid has the highest amount of energy? So generally, the major component of lipids, is actually made up of fatty acids. The major component of lipid is fatty acids and glycerol. And also, I want to mention something here very important. The most important storage lipid in our body is tag. Is tag. What is tag? Tag is triacyl glycerol. So that is the major storage carbohydrate that is found in our body. So we have tag. So tag is a major carbohydrate that it's actually a major lipid that actually store in our body. We call it triacyl glycerol. So you see, this triacyl glycerol, it means that in the tag there are three fatty acids. There are three fatty acids and one glycerol. And if you look at the fatty acid, ladies and gentlemen, you can realize that the fatty acid is made up of a functional group of carboxylic acid, and it has the R side chain. The R side chain, usually it can be something like this: CH3, CH2. This CH2 here can be 10, and COOH. As you can see here, it's a fatty acid that contains 12 carbon. So if you look at this fatty acid, please get it very well, because as I said, I will tell you some of the reason why the fat produce more energy than the carbohydrate, and this is a kind of questions that I think I saw it in some various past question paper. So look at this fatty acid with 12 carbon. Look at the number of hydrogens that are there. Look at the number of hydrogens that are there. I think there are many. The number of hydrogens is huge. Check very well. The number of hydrogens, if you look at it very well. The number of the hydrogen is huge. So remember, ladies and gentlemen, from your basic chemistry or your very basic concept of chemistry, oxidation and reduction, when you say reduction, it means addition of hydrogen. So if you look at this fatty acid, it contains high amount of hydrogen. It is fully loaded with hydrogen. So because of that, we can say that fatty acid is highly reduced. Is highly reduced. What makes it to be highly reduced is because of the number of hydrogen atoms. So because of this reduced nature of fatty acids, that is what make it to form, that is what make it to have high amount of energy than any other class of carbohydrates. Please, are you following, ladies and gentlemen? Are you following? Please, are you following? So I hope now you understand and you know the reason why carbohydrates generate energy more than any other class of food. Okay, I said the reason why lipids produce higher amount of energy than carbohydrates and proteins is because lipid is highly reduced. What makes it to be highly reduced? Because of the number of hydrogen atoms. So therefore, the number of hydrogen atoms in the fatty acid is what makes it to be highly reduced. And this reduced nature of the fatty acid, that's what makes it to generate more amount of energy than any other class of food. I hope this is clear. Okay. So then another functions of lipid, ladies and gentlemen, who can give me another functions of lipids? Another functions of lipid, please. Another functions of lipid. Please, I want you to be telling them this is where we are doing the class. What is another functions? Okay, they serve as a major energy. Yes, they serve as the structural component. They serve as a structural component. They serve as a structural component of cell membrane. So you see, ladies and gentlemen, I think even before now, we have actually discussed that a lipid is one of the major structural components. If you look at the lipids, if you look at the cell membrane, the membrane of the cell, remember, it is responsible for controlling of what will get into the cell and what will go out of the cell. So that is why it serves as a structural component of cell membrane. And specifically, we have different types of lipids. And I know that you watched this video on the issue of the lipids. So now my question is, who can tell me specifically the major class of lipids that is found in the membrane of the cell? Please, who can give me this answer? The major class of uh, lipid that is found in the structure of excellent blessing Chinedu. Excellent. The answer is phospholipids. So phospholipids is the major lipid that found on the cell membrane of the cell. Thank you very much. I like the way you are responding. And that shows that you really watch the videos that I sent to you. So then who can give me another functions of lipids? Thought. Another functions of lipids. Another functions of lipid, please. Another functions of lipid. Idara Friday, you are welcome. It helps to protect some of organs. Yeah. So, but what is the modesta? What is, yes, heat regulator or thermal insulator? Yes, thermal insulator gives. It serves as a thermal insulator. It serves as a thermal insulator. So what does that mean to consider lipid as a thermal insulator? Okay. Generally, ladies and gentlemen, we have some delicate organs in our body. We have some delicate organs in our body. And examples of these delicate organs, we have our kidney, we have our liver, we have our heart, and so many organs. So this lipid usually is found to cover these entire organs. So that is why sometimes, you know, the reason why fat people usually don't get, or when there is a cold weather, it's actually the cold weather doesn't usually affect them. And if there is hot, it affects them significantly. The reason is because the lipids are there, so it's trying to actually protect or control the amount of heat and then the amount of cold that can get into our body. So that is why it serves as a thermal insulator. So this is actually the third functions of lipids. So there is what you call actually subcutaneous organs and tissues. So it really actually help them and protect them. Excellent. Mirabel, it produces hormones. Yes, It involves in the synthesis of steroid hormones. It involves in the synthesis of steroid hormones. Number 4, it involves in the synthesis of steroids hormones. Please, who can give me examples of steroid hormones? Who can give me examples of steroid hormones? I need one example of steroid hormones. One example of steroid hormones. Excellent. Corticosteroid, aldosterone, testosterone, progesterone, all are examples of the steroid hormones that are synthesized using lipids. Excellent. Cortisone, all of them are examples of that. And then we also have number 5. It involves in the you know what you call lipoproteins. We have what you call lipoproteins. What are lipoproteins, ladies and gentlemen? Lipoproteins are class of proteins. Lipoproteins are important in transporting lipids. So usually when we digest and absorb lipid, it is this class of lipoproteins that help in terms or that help in transporting the lipid from small intestine to the target organs. And examples of these lipoproteins, we have HDL, we have VLDL, and we have LDL. So it serves as also a transporters. So please, ladies and gentlemen, what I want you, as you are watching or as you are present in this live video, please check on subscription box, and if you didn't subscribe, please click on it so that you can easily subscribe. This is another YouTube video where I'm doing anatomy and some questions related to biochemistry. So you can click on subscription so that you are now become a subscribers to this YouTube channel so that you can also have access. So just click on subscription. So now these are actually some of the functions of these lipids. So now the next thing that we are going to look at is classification of lipids. Classification of lipids. Classification of lipids. So who can tell me the first class of lipids? Classifications of lipid. What are the classification of lipid, please? A lot of people were waiting on the order link. Please tell them that we are using this one. I even said it on the WhatsApp group. So what are the classification of lipid? Excellent. We have simple lipids. We have simple lipids. Excellent. And then number 2, we have complex lipids. We have simple lipid, we have complex lipids, and then number 3, we have derived. We have derived lipids. So these are the different types of lipids that we have. These are the different types of lipid that we have. We have simple lipids, we have complex lipids, and then we have derived lipids. So now, what are the types of simple lipids? What are the types of simple lipids? We have different types of simple lipids. So what are they? Yes, simple lipid, complex lipids, and excellent. So Sylvester says under simple lipid is divided into 3. We have fats. We have fats, number 1. We have oils. We have waxes. So these are the examples, or these are the types of the simple lipids that we have. We have fats, we have oils, and then we have waxes. So these are the different types of lipids. So we have fats, we have oils, and then we have waxes. So now who can tell me, ladies and gentlemen, what is the difference between fats and oils? What is the difference between fats and oils, please? The differences between fat and oil. What are the differences between fat and oil? Yes, fat is solid at room temperature. So, but what makes it to be solid at room temperature? So you see, let me show you. Now, fat is made up of saturated, saturated fatty acids, and glycerol. So you see, the fat is made up of saturated fatty acid and glycerol. And then for the oils, it is made up of unsaturated fatty acid and unsaturated fatty acids and glycerol. So please know the differences. So that is why, because fat is made up of saturated fatty acid and glycerol, so that is what makes it solid at room temperature. So it is solid at room temperature. That is 25 degrees centigrade is the room temperature. While oils, it is liquids at room temperature. It is liquids at room temperature. That is 25 degrees centigrade. So that is the difference between fat and oil. And we are coming to talk about the fatty acid as well as the differences between saturated and unsaturated fatty acids. So then the next one is waxes. Please, I want you to be getting this very important. The first class of lipid, we have simple lipids. And this simple lipid is classified into three. We have fats, we have oils, and then we have waxes. Fats, it's made up of saturated fatty acid and glycerol. Oils is made up of unsaturated fatty acid and glycerol. And then what about waxes? So you now see the differences between this. So what is waxes? So waxes, it is actually made up of fatty acids, is made up of fatty acids plus high molecular weight, high molecular weight monohydric alcohol. So see, I think you can now clearly see the differences. Waxes is made up of fatty acid plus high molecular weight monohydric alcohol. Excellent, Peter Alexandra. So waxes is made up of fatty acid with high molecular weight monohydric alcohols. Excellent. So, so these are the differences between these three classes of fat, sorry, classes of simple lipid, waxes, oils, and fats. This is actually okay. Fat is solid at room temperature. So what make it to be solid at room temperature is because it is made up of saturated fatty acid and glycerol. And then for the oils, it is unsaturated fatty acid uh, because of this unsaturated fatty acid, that is what make it to be liquid at room temperature. And then waxes, it is made up of fatty acid plus high molecular weight monohydric alcohols. Please, is that clear, ladies and gentlemen? Does that make sense? Please, as I said, as you come to this, please check on the subscription and then click on subscribe, and then follow, turn on your notifications so that whenever there is a new video, then you can have access to the videos. So now the next thing that we are going to look at is actually the complex lipids. The complex lipids. So now complex lipids. So what is complex lipids? What are complex lipids? So when you said complex lipids, there are lipids that made up of fatty acids. They are lipids that made up of fatty acids plus glycerol plus other compounds. So you see, why simple lipid is simple is because it's just made up of fatty acid and alcohol. Fatty acid and alcohol, irrespective of the class of fatty acid and the class of alcohol. But in the case of complex lipids, you see, apart from the fatty acids plus glycerol, it also contains other compounds. It also contains other compounds. You see, so the differences between complex lipids and the simple lipid is that in the complex lipids is made up of fatty acid and glycerol from other and plus other groups. So that is what make it complex. Please try to be differentiating these things. So complex lipid, fatty acid plus glycerol, and other compound, that is what make it complex. Simple lipid is simple lipid because it's made up of fatty acid and alcohol. Is that clear? No, fatty acid, glycerol, and other atoms, other compound. Godiya kaham. Okay. So now who can give me examples of a complex lipid? The classes of the you see, under simple lipid we have fat, oils, and waxes. Then what about complex lipids? Complex lipids. What are the okay? No, I am asking. No, Sylvester. Yes, examples of other compounds, it can be ethanolamine, it can be carbohydrates, uh it can be carbohydrates, it can be sulfur group. So now let's look at the examples of the of the complex lipids. So we have number one, we have phospholipids. Excellent. We have phospholipids. So phospholipid is an example of a complex lipid. Is an example of complex lipid. So in the okay, fatty acid are solid usually from animals. Yes, Habiba. Habiba, I also agree with you. So now we are talking about phospholipids. So who can tell me in phospholipids, apart from fatty acid and glycerol, what other groups are there or what other groups are found? Yes, good evening. What other groups do we have apart from fatty acid and glycerol in the case of phospholipids? Yes, excellent, Sylvester. Excellent, Sylvester. So you see, in the case of phospholipids, look at it, it contains fatty acids, number one, plus glycerol, plus phosphatidic acid. Phosphatidic, phosphatidic acids. So that is in the case of phospholipids. So apart from fatty acid and glycerol, it contains phosphatidic acids. And we also have different types of these phospholipids. Different types of phospholipids. We have different types of it. So who can tell me? We have glycerol examples of this phospholipid. You can have glycerol, glycerol phospholipids, phospholipids. So what do you mean with glycerophospholipids? It means that apart from fatty acids plus glycerol and phosphatidic acid is also contain another glycerol. Excellent sulfolipids. Then another examples of this phospholipid, we also have sphingosine. Sphingosine. Or we can, sorry, not sphingosine, we have sphingolipids. We have sphingolipids. So sphingolipid is also another example of phospholipid. So what is sphingolipid? Sphingolipid, it's not actually, or it's a lipid that doesn't contain glycerol. Rather, the alcohol there, the alcohol in sphingolipids, the alcohol in sphingolipid is sphingosine. Sphingosine. So it doesn't have glycerol. Rather, the the alcohol there is sphingosine. So sphingosine is the alcohol that is found in the sphingolipids. Yes, you can call it sphingospholipids or sphingolipids. So let's leave it as sphingophospholipid. Sphingo, because we are talking about the different types of phospholipids. So let's say sphingospholipids. So sphingophospholipid, it contains sphingosine. Yes, excellent, Modesta. So this is actually the different types of the phospholipids. Shafa'atu Abdullahi, you are welcome. We also have glycolipids. So all these are examples of phospholipids, and I know that you watch them from the videos. So another examples of complex lipid apart from phospholipid, we have glycolipids. We have, so B, we have B, glycolipids. So glycolipid is also another examples of complex lipids. Glycolipid is also another examples of complex lipids. So when we said glyco, it means sugar. So it contains sugar. So it means that it's a lipid that contains fatty acids, glycerol, plus carbohydrates. So you see, in the case of phospholipid, it contains fatty acid, glycerol, plus phospholipid, sorry, plus phosphatidic acid. And then for the glycerol lipid or glycolipid we have, it has fatty acids plus glycerol plus carbohydrates. So that is why it calls glycolipids. So we have so many other examples of this phospholipid. We have even lipoproteins. See, we have lipoproteins. It means lipid and proteins. We also have sulfolipids. Sulfolipids. So all these are examples of complex lipid. We also have amino lipids. We have amino lipids A, B, C, D. We have E, amino lipids. Amino lipids, that is amino acid plus lipids. So all these are examples of the complex lipid. Please, ladies and gentlemen, do you understand? If you check the previous video that I sent to you, you will realize that all these things are there. We are just revising. We are just revising. So that is why, ladies and gentlemen, I want you always to understand that I am taking my time to do all these things so that at least when you come to write your examination, you will find it easy. You see, sometimes I will send you videos before the lecture, and then after sending you the videos, then we'll also have a lecture. All this is just to make the examinations simple and cheap. So that is why I'm doing this. Please, ladies and gentlemen, don't disappoint me. I want you to pass these exams very well. I want you to pass with a very good grade. And I'm telling you, this is not the first time. A lot of people are happy. A lot of the students that graduated, or a lot of the students that passed through DLC, especially those that I took biochemistry, they are very happy and they used to pass with a very good grade. So that is why sometimes I'm taking my time sending you video links and then taking my time to teach you. You see, this is as if like you are in normal class. This as if like we are in normal class. I'm using both. I bought my own marker all purposely because of you. So because my hope is that at the end you'll be able to be happy with what you learn and also apply it in practice. Because sometimes it's not actually about getting the grade alone. It is about understanding the content of each of these courses. So that at least whenever you go for your practice, you will appreciate them. So that is why you will see that I'm even taking some other courses in order for you to be able to pass them with a very good grade. So I did physiology, I did anatomy, I did biostatistics, biochemistry, anatomy, all of them. So all this is just actually for you to be able to pass them very well. Sometimes I know that you are committed, you are too much engaged with so many activities, but the best way sometimes to pass the examination, try to develop a habit of reading every day. Try to develop a habit of reading every day. Don't actually come up with the habit that you will only read when you have examination. Please, please don't develop that habit. Try to develop a habit of reading every day. So that is when to learn. That is when you will be able to attempt and answer questions wherever you find yourself. So that is why each and every step, follow it. Read very well. Read very well. Because you will be happy. You will be happy to still have a knowledge after writing examination. So that at least whoever actually come to ask you simple questions, or when you are addressing problems, people will actually be happy that yes, this guy or this really knows what he is doing or what she is doing. So how do you do that? What is the importance of even doing biochemistry? Is to help you to be solving complex problems. That is why you see all these things that we are doing is under cell. So nobody will tell you what cell it is, like somebody that studied biochemistry very well. And of course, remember, look at the physiology, you started with cell. Look at anatomy, you started with cell. All the two physiology, you started with cell. And also biochemistry, you started with cell. It's because the cell is the structural and the fundamental unit of life. And there is no way There is no way that you will be able to understand disease mechanisms. There is no way that you will be able to diagnose a disease. There is no way that you will explain life without understanding the content of cells. And what makes you to understand the content of life is to be able to understand what is there in the cell, the different organelles of the cell. So how do you have that different organelles of the cell? Remember, they came from supramolecular complexes. And how will you be able to understand supramolecular complexes? Is by you able to understand the macromolecules. And what are those macromolecules? There are molecules of large molecular weights. Examples, we have protein, we have lipids, we have carbohydrates, we have nucleic acids. So how do you understand these macromolecules? Is by you be able to understand the monomers that form them. Amino acids are those monomers that generate proteins. Fatty acid and glycerol produce lipids. Nucleotides produce nucleic acid, that is DNA and RNA. So how do you get those monomers? Is from simple molecules. And from that simple molecules, how do you get them? Is from atoms. And how these atoms come from? Is from the particles, that is protons, neutrons, and electrons. So that is why everything started from chemistry. Everything started from chemistry. That is why, ask yourself, if you are a bad student in chemistry, so you are definitely going to be a bad student in biochemistry, physiology, and anatomy. Because sometimes you'll just be reading. But if you are actually someone that was able to understand chemistry, you'll definitely going to have a details understanding of whatever you are going to do. And mathematics is what gives you the logical thinking. If you are good in mathematics, you can actually have a logical thinking. So that is why I always advise students, if you want to become a very good student, forget about your age, forget about whatever it is. Read very well. In your profession always come with knowledge. And how is that knowledge translates? Is by knowing exactly what you are doing. How are you going to know what you are doing? Is by attending classes. Learn from different peoples. That is how you do things. So I'm just advising you, don't actually become someone, or don't be someone that will only read when you have examination. So if you are like that, you will you will end up of confusing yourself. You will end up confusing yourself. So that is why I'm taking my time. At least every week we will have class. So for those that are serious, will definitely come to the class. Like, look at the number now. 24. Although the videos is always there and you can come visit and read it again, but it is always to try as much as possible to come on the right time, listen to the lecture, and whenever you have any problem or you have any issue, you go back to it. So please do that. So all these things that I'm seeing now, I have already explained them in the other videos that I sent to you. Yeah, but I think now the network is okay. Can you hear me, please? Can you hear me? Please, are you with me? Okay. So please, as I said, try as much as possible to uh and understand most of these things that we are doing. So I think the next types of lipids that we are going to look at is dry lipids. Or can we stop here? Can we continue or we should stop here? Can we continue or we should stop here? Please, can we continue or we should stop here? Okay, so let me finish it. So I think actually when you said derived lipid, what is derived lipids? Derived lipids, they are lipids that are produced as a result of hydrolysis or as a result of breaking down of simple lipids and the complex lipids. So that is what you call derived lipids. So derived lipids, they are lipids that are produced as from simple lipids and complex lipids. So that is why they are called dry. So as a result of the hydrolysis of simple lipids and the complex lipids, so that is why, no, that is, I think that is all. That is all actually for the derived lipids, I think. And most of these things you have already watched them. You have already watched this. So derived lipids, they are lipids because they are hydrolyzed from simple lipid and the complex lipid. So they are from the complex lipid and they are from the complex lipid and the simple lipid. So that is why they are called derived lipids. Examples, we have glycerol, steroids, fatty aldehydes, ketone bodies. All are examples of this derived lipid. Please, I'm advising you, if you did not join the other WhatsApp group for the tutorial, and if you are not also a member to the other YouTube channel, that is my main YouTube channel where I'm doing biochemistry, physiology, biostatistics. This is the only YouTube, this YouTube that I'm using now. It is the one that I'm using for the anatomy. So all the anatomy videos are under this YouTube. So that is why I said if you didn't subscribe, please check on the subscription and click on it. Click on it. If you didn't subscribe, please do that now. And then for the other courses, if you want to join, please try to join the membership so that at least you can have access to all these 5 videos without having problem. And there are a lot of videos that I use to solve fast question papers. There are a lot of videos and I'm going to continue that. I think even today, I sent solution to fast question paper to the tutorial group. And I'm also going to continue with that. So please, ladies and gentlemen, we are going to end it here. So don't forget to subscribe to this channel. And if you want to join the membership for the other YouTube, you can talk to me. Thank you very much and see you next. Bye bye.